Hola, my name is Pamela. Welcome to my channel. Today I'm gonna talk about to understand how magnetic meters work, we must know Faraday's law. This establishes that the induced voltage of a conductor is proportional to its speed when it moves perpendicularly through a magnetic field. The law of the right hand tells us that when the palm of your right hand is perpendicular to the lines of force of the magnetic field and the fingers are in the direction of the fluid current, then the thumb points in the direction of the induced current. This being the flow formula given by Faraday's law. To obtain a signal that depends only on speed, the influence of these three factors must be eliminated. In the magnetic flow method, the conductor is the liquid and the generated signal is captured by two electrodes, flush with the inner surface of the tube and diametrically opposed. The generated signal depends on the speed of the fluid and the density of the magnetic field, which is influenced by the line voltage and the fluid temperature as indicated by these formulas. To obtain a signal that depends only on speed, the influence of these three factors must be eliminated. These three factors are difficult to keep constant, since the temperature and conductivity of the fluid are determined by the service conditions. Therefore, the voltage signal from the meter is compared at the receiver with another voltage called the reference voltage. Both are derived from the magnetic field. Line voltage and variations in temperature and conductivity do not influence the precision of the measurement. The reference signal is taken from a winding placed in the field windings that generates the magnetic flux. In this image, we can see the connections of the measuring element. The value of ER is chosen in such a way that the ES and ER ratio becomes constant in all flow meters, and thus its interchangeability with any receiver is achieved. The ER value transmitted by the receiver can be set with complete accuracy, thanks to a potentiometer normally placed on the meter and factory set for the maximum flow value. The flow measurements in both directions of flow of the fluid can be done in two ways. With a switch that reverses the receiver signal connections. The position of the switch indicates the flow direction, and the system calibration remains unchanged in any direction. B. Raising the zero of the instrument to 50% of the scale, in which case the index automatically indicates the direction of the liquid flow, being in the upper and lower zone of the scale. The system calibration remains unchanged, and the indication is minus 50 or plus 50% of the scale instead of 0 to 100%. The conductivity of the fluid is the only characteristic that can limit the use of a magnetic flow meter. The electronic system in the element and the receiver allows to measure flow rates of liquids with conductivities higher than 3 microohms per centimeter. But an additional preamplifier or signal conditioner can be added for lower conductivities, reaching a minimum conductivity of 0.3 microohms per centimeter. However, with flat electrodes, not in contact with the liquid and insulated within the layers of the coating metal and coupled capacitively with the process, it is possible to measure flow rates of liquids with conductivities as low as 0.05 microohms per centimeter. Some manufacturers drive the magnetic field coil at low frequency instead of using the line frequency. This is to increase the precision and the zero stability of the meter. There are also manufacturers who use direct voltage sources with short periods instead of feeding the field coils with alternate current. In this way, the system consumes less. The cost is low, and its installation is easier. They are less sensitive to electrode coating problems, but their response is slower, which is unacceptable for certain types of control. Other manufacturers feed the magnetic field coil with two superimposed waves, one of low frequency, which gives a very good zero stability, and one of high frequency, that is immune to the noise generated by the high viscosity of the liquid, electromechanical reactions, and/or low conductivity. The length of the cable between the element and the receiver should not be that long. This type of meter does not serve to measure the flow of gases, since their conductivity is much lower than that of the liquids. Magnetic meters are sensitive to noise signals, for example, those caused by high-power electric motors near the meter. as they generate a magnetic field that can overlap the flux from the meter itself. The reference voltage system is responsible for eliminating this type of noise. Other motors and electrical lines can also generate currents and electrical voltages in the plant pipes, being captured by the meter in the form of voltage signals. To reduce the influence of these signals, the meter connection flanges are electrically bypassed and grounded, which has proven not to work in practice. So many manufacturers have already installed systems in the receiver to remove them. Whenever the conditions that cause noise vary, it is necessary to correct the compensation system. However, this would no longer be necessary if a third electrode is inserted into the meter and grounded, since in this way, the unit of measure is grounded to noise signals, and is completely insensitive to noise signals without position adjustments may have to be made at installation. And well, this will be all for today's video. Don't forget to give me a like and subscribe. I upload videos every Wednesday in Spanish and every Friday in English. Adios! To understand, therefore, the voltage signal. Both, both are the flow measurements in both direction of flow of the fluid characteristic that can limit the use of a magnetic flowmeter.